Okay, section 8.1. So this unit is going to finish up with section 8.1 and 8.2, and then we're going to stop and we're going to have a test on the third unit. Okay, so we have today, and then we have Wednesday. No, today is Tuesday. So we have today and Thursday. I don't ever know what day it is anymore. I don't know why, it's a personal problem. So we've got that, and then we'll have our next test on this kind of short unit on next week from today. Then the unit after that is just 2 sections. So what really has happened is in the past, I've taught this whole thing as 1 unit, and there was just 5 units in the class, but it becomes a lot to have to remember. So I broke it up so that there's the better success rate. So section 8.1, what we're going to talk about is we're just going to talk about some basic geometry terms. Then we're going to apply some stuff we've already learned in this class to do some basic operations of things. So geometry, I'm not going to give you the whole history lesson, but the prefix geo means earth. And so this was, geometry was devised when people were curious about, of course, before satellites thousands of years ago, when people were curious about how big the earth was and how far away the stars were and how to navigate places. So this branch of mathematics developed historically out of the desire to measure the world around us. And then it became from there the ability to prove things and to kind of use geometry, then developed into physics and the ability to travel and to move and to do all sorts of crazy things. So that's why we're going to get a little bit of a foundation here. So we're going to start with just some basic terminology. So for instance, a line is simply just a set of points something you may or may not remember. I think a lot of students take geometry in high school. I don't know if that's true of your past. But one of the definitions we know is that 2 points determine a line. Lines are one of those things that are hard to define because I told you a line is a set of points, but there's lots of sets of points that aren't lines. So we know that lines are things that go in 2 directions. So I think we would all recognize this right here as a line. I'm putting the arrows on it because a line never stops. Okay, it goes forever and ever and ever in both directions like that. If it does stop either on one end or another, it's called something different. And we're going to talk about that. We're going to talk about that and the differences, in fact, right now. So if you have a line and you just take a part of it, so for instance, in this line, if I have a point right here, I'm going to call that point A, and a point right here, I'm going to call that point B. And I'm not interested in all the stuff that goes on forever. I'm just concerned about it starting at A and ending at B. Okay, what that is called in geometry is a line segment. So the line segment is a portion of a line. Between 2 points. And it includes the endpoints. So let me show you a little terminology and how to write these things kind of quick and how to read these things as you're doing your problems that you're going to be doing. If I want to define a line, if I want to express it, here's how you'll do it. Because 2 points define a line, you pick 2 points that are on the line. I've only got 2 right here. And I'm going to say AB. And on top of it, I'm going to put a little line symbol. I'm going to put an arrow with 2 arrowheads. Okay, that means line AB. That's what that means. If you're interested in the segment, Okay, so if you're not interested in the line that goes on forever, if you're just concerned about where it starts and stops, again, you use the A, B, you use the starting point and the stopping point, but instead of a line on top, instead of the arrows, you just put a segment on top. You just put the line without the arrows. Okay, that means segment. So it's important to be observant when you're reading these problems to know what you're talking about. So this is segment. AB. Now we can do some other things with those endpoints. There are such things that I don't care about the endpoints. All I do is care about the stuff that's in between them. So for instance, if I have AB and you see this symbol over it, it looks like a barbell. So you've got an open circle on one end and an open circle on the other end. What that is called, when you don't include the endpoints, when you don't care about them, that's called an open segment. So open segment AB. And then one other thing that you're going to see some on your problems, that's why I'm making sure to notate it for you, is there are situations where you care about one end and not the other end. So for instance, if you see something like this, AB with a segment looking thing, but then it has a circle inside, so it looks like a lollipop. Okay, and then what that is that's a half open segment. So those are the different types of lines and segments that you will see. Now there's something else. There's one more thing, and then we're going to do a few problems, and then I'll introduce some other things to you. Okay, there's another thing. So that's kind of lines, but in segments. But we can divide it up a little more too. We can talk about something called a ray. Like a ray of sunshine. A ray is a figure that starts at a point and goes in one direction. So for instance, on my little diagram right here, I'm going to erase this part of the line. And now what I have is I have a ray. I have a ray that starts at A and goes in the direction of B. So I'm going to show you the notation for that. So if I have my AB letters, okay, rays are specific. These other, well, except for the open segment, doesn't matter what order you put the A and the B in, it's still going to be a line. Doesn't matter what order you put the A and the B in, it's still going to be a segment. But here, when I put my arrow like this, this tells me the direction of the arrow tells me where the ray starts. It starts at A, and it tells me what direction it goes. It goes in the direction of B. If you wrote this, AB, but then you drew the arrow the other way, what you're communicating is not what that picture is. What you're communicating is the ray starts at B and then goes in the direction of A. So it would be something like that right there. It's the reverse. Okay, so just keeping that in mind. For rays, the order matters. And then the last figure, and then we're going to do some problems just to have a little bit of fun here. The last thing is if I have AB, but instead of including the point on the end, if I don't include the point, so I put an open circle there, what this is called is a half line. Okay, so that is more terminology than you definitely bargained for right here. So what we're going to do is I'm going to turn on the document camera, and I gave you a piece of paper. If you're watching this on video, this is attached as a PDF, so you can print it out and write on it. So what we've got is a piece of paper with several figures. What we're just going to do is we're going to practice doing some operations involving these different things that I've just written on the board. So for instance, here's what I want to do. I'm
I'm going to start with the line that's defined up at the top. We've got 4 points that are on that line just so that we have a touch of a variety here. And so I want to know the following. I want to know what happens if I take AB with a segment on it and I union that with BD with a segment on it. So this is relying on just a little bit of prior knowledge. So you're going to help me remember, okay? And if in case you don't remember, that's okay. We'll remember it together. What does this symbol, what does union mean? When we were talking about sets, yeah, join it together. You take everything in both of these sets, okay? Because in geometry, these figures just represent sets of points. Okay, so I'm going to just trace on here what AB and BD are, and then we're going to see what the result is. So AB is segment AB, so it's the segment that starts at A, so I'm going to put a dot, and goes to B, I'm going to put another dot. And then BD, I'm just going to do a different color here. It starts at B and then goes all the way over to D. So if I join those two things together, if I union them, so that means I'm smushing it all together. What do I have when I union those together? I'm sorry? Okay, you've got it reversed. That is a great question. What you just did, I'm going to write it down because it's such a good question. You took segment AB and you intersected it with BD. The intersection is what they have in common. And so you answered the question. So this is great. This gives me an opportunity to tell you a little bit about notation. So the intersection, what's wrong?
This is not bringing back good memories.
No? Well, hopefully we'll make some good memories. So this is my intersection. The intersection is what they have in common. And so when I'm looking at these two figures, what they have in common, just like what you said, is B. That's the only place where they overlap. And so the way you would write that is you have a choice. I don't remember which one my math lab uses. They'll tell you. I don't care which one you use. You can either write B in a squiggly, set B, or you can write a little dot right in front of B to mean point B. Okay, those are the two bits of notation for that. So thank you for making up a good question. That's good. That's the intersection, but that's not what I asked originally. I asked union, and the union means to join two things together. It means take everything in both sets. So if I take everything that's red and I combine it with everything that's blue, what do I have? AD, I start at A, and then I go continuously all over to D. So what that's going to be equal to is it's going to start at A, and it's going to go to D, and it's just going to be a segment.
So you're never going to like draw a segment.
No, segments do not. That's a great question because I see students do this all the time. So let me just get this out in the open now. When I define this segment, I do not write this as segment A, B, D like that. I get what you're driving at there, but that is wrong. A segment, to define it, you just say the starting point and the ending point, and then it's implied that you're including all the points. So I'm going to put an X through that because that is not quite right. All right, what I would like you to do, if you need to, I have a couple spare ones of these. I don't have enough to give everybody two, but it's a simple enough figure to draw in your notes. What I would like you to do, I've got spares here just so that I don't create a huge mess. Here's one for you. I want you to give this a try. Do the best you can. I know this is difficult stuff. That's why I'm trying to go slow. I would like you to do this. Let's say that I have BC segment. This time I want to union it with the ray that goes from C to D in that order right there. Okay, so we've got segment BC. Again, we are performing the union, which means join together with CD. So determine what the figure is and then how you're going to label it. All right, so I'm going to give this a try. Let me know how you're doing. So again, BC, that denotes a segment. So it's starting at B and it's going to C. And then CD is a ray. The ray starts at C. That's what this arrow is telling me. It starts at C, goes in the direction of D. So that's this direction right here. I'll label D on here so that we have it. Okay, so now, when I union, again, I'm joining these together. What sort of figure do I get? Let's not worry about labeling it. We'll talk about that in a minute. But what sort of figure do I get when I union and I take all of these points together? I'm sorry? What BD, that'll be good, but it's a array. So yes, and we're going to call it, there's two answers that would be correct here. Okay, it's a ray because it starts at this point B and it goes in this direction right here. So it's a ray. No matter how you label this ray, the starting point is B. Okay, that's very important. That's where this starts, at this point right here. The direction it goes, though, you have a choice. You can either do what Caitlin told me, right? Got that right? Okay, you can either do what Caitlin said and said BD because it starts at B and goes in that direction. That's fantastic. Well done, 100%. Or again, it's a ray starting at B, but the direction is just telling you which way it's going. You can say it's ray B going in the direction of C as well, because C is also in that direction. Either way, that is perfectly good answer to the question. Here's another one that I'm going to give you. Again, pretty easy figure to draw. Here's what I would like you to do. I would like you to determine what, if I ask this, let's say we have ray BC, and this time we're intersecting it with ray DB, starting at D going in the direction of B. What is that going to be equal to? Notice we're intersecting this time. All right, let's see how you did. I've got one more that we're going to do on this figure, then I'm going to define something else, and then we'll come back and we'll do a couple more problems on this sheet. So let's say BC is the ray that starts at B and goes in the direction of C, so that direction right there. And then DB, notice the arrow, the starting point of the ray is at D, and it goes in the direction of B, like this. So I'm intersecting. So what do they have in common? What is the result here when I intersect? What'd you say? I'm sorry. Okay, great. Notice what they have in common goes from here to here. That's where both the red and the purple on my drawing are. And so there is a definite starting and stopping point of where they are in common. And so the starting point is B. The ending point is D, and the figure that has a starting and a stopping point is called a segment. So I put a little bar over it. If you did DB with a segment over it, that is fine. Okay, the order does not matter in your segment. Okay, I usually just go alphabetical, but that is not urgent. One more. I'm going to do one more, and then I got another figure we're going to talk about, and then we're going to come back and have even more fun. So I'm going to actually give you the same two things we just did. let's say that you have ray BD. This time, though, instead of intersecting it, we're going to union it with DB. Union, remember, union means join together. It's taking everything in both sets. Okay, so it's the same. I actually didn't need to make a new drawing, but I did just because. So now it's the same two things. It's ray B going in the direction of D, and then ray D going in the direction of B. Okay, so now what do I have when I union them, when I smush it together and I take everything? What is that figure? It's a line, okay, because when I union, I take everything. So I've got all this stuff out here. I got all the stuff they have in common, and I got all the stuff out here. So it turns out to be a line. So I'll use the symbol for line. Now you have a lot of liberty here when you're defining your line. Remember, it takes 2 points to determine a line, and it doesn't matter which 2 points you use. So as long as you picked any 2 of these 4 letters that you have down here, you have correctly determined the line. So if you said that it's line BC, that's fantastic. Or if you said it was line AD, that's fantastic. Or if you said it was line CD, great. And there's other options. I'm not going to bore you more than I already am listing them all. Okay, so any 2 things. The important thing there is seeing that the union, when you're joining those 2 things together and you're taking all the points in both rays, it goes in both directions forever, and that is what's called a line. Okay, we'll come back to those drawings in just a minute. I'm going to change back to my other camera here, so hopefully that doesn't make you too dizzy if you're watching the video.
And now is another figure. So we've talked about lines, we've talked about segments. So now, and rays. So now we're going to talk about what an angle is. So an angle is 2 rays that share a common endpoint. So for instance, the way I would draw this is, let's say that I have this ray is A and goes in the direction of B. And then this ray is A and goes in the direction of C. That's an angle. Okay, I've got 2 rays that share a common endpoint. So just a couple bits of terminology here. This endpoint that they have in common, this is called the vertex. So when you see or read that word, that's called the vertex. That's the point where they overlap. And then the edges here, these are called the sides of the angle, sorry. It's called the sides of the angle. Notationally, if you want to tell your friends and relatives and neighbors about this angle, here's how you would notate it. You use a little angle symbol. So when you're doing your homework, you're going to see a little angle symbol. It looks like a mouth coming to eat. And then you use the letters that are defined on this angle. The only caveat here is that the vertex has to be the middle letter. So there's 2 ways you could label this angle. You could call it angle BAC. BAC. You're defining the sides and the vertex of the angle, or you can call it angle CAB. If you like to make words, angle CAB. Both of those are very nice ways to label this. You would not say that this is angle ABC. Angle ABC would be referring to something different if somebody's reading this. It's assumed that the letter in the middle is the vertex when you're labeling things. If I tell you that angle BAC, I'm going to erase the word sides because I don't want to jumble things up too much on the board here. If I tell you that the angle BAC, I almost made that mistake I told you not to make, so good for me. If I tell you that the measure of it is 35 degrees, we use things called degrees. There are 360 degrees in a circle. Okay, so that tells you, it can give you an inclination about how much a degree is. If I pretend that this is 35 degrees, which I don't really know if it is, and we don't have a giant protractor here, but let's pretend, then the way you would communicate to people, again, notationally, is that the measure, you use a little m in front of the angle symbol. So the measure of angle BAC is equal to 35 degrees. And just showing you, all I'm doing here is I'm just trying to show you how you interpret the things you're going to read on your homework. When you see the angle symbol alone, it's just defining the angle. If you want to tell how big that angle is, then you put a little m there. That m stands for measure. Okay, so we're going to do a couple more problems on the sheet. Then I've got a few more things to tell you about angles. And then there's one more bit of trivia. If we get to it in this section, or if we get to it today, great. If not, we'll just lump it in with next time. It's about what's called parallel lines. So if you go to do your homework and we don't get to that last little bit, just at the very end of the homework, just skip the problems about parallel lines and come back to them next time. Okay, so we'll see how that goes. I don't want to rush it. I've already been told that we're bringing back some horrible, tragic memories from previous math classes. I understand.
And I've had those, but my horrible, tragic memories were in English classes. So that was, all right. So here we go. What I would like you to do for me in this middle picture that I've got for you right there, just going to do 2 or 3 problems like we were doing earlier, can involve lines, segments, arrays, or angles now that we have that. So what I would like you to do, please, is I'd like you to write down what we get if we take ray Fi and we union it with ray Fg. Okay, what is that figure when you union those two things together? All right, so ray Fi. So ray Fi, it starts at F and it goes in the direction of I like that. And then ray Fg again starts at F and goes in the direction of G. And what kind of figure is that those two rays form? It's an angle. And then yes, there's 2 ways you can label it that are both correct. These would be the 2 correct answers. Okay, you would either say it's ray IFG, or you would say that it's, or excuse me, angle IFG, or you would say it's angle GFI. You cannot do those three letters in any other order. You would not say, okay, so this would be bad to just say angle F. Okay, sometimes people label angles with just the vertex, and that's allowable if there's only one angle, but you have 4 angles all tied together at that vertex. So this would have no meaning. So you would not write that in this particular instance. Here's another problem that I would like you to do on that same figure. Let's say that we have this. Let's say that we've got ray AC and we are intersecting it with ray EF. Okay, so ray AC is the ray that starts way out here and goes in this direction, whee. And then ray EF starts down here and goes in this direction, whee. And if we intersect those this time, intersection means what do they share? What do they have in common? What do those two rays have in common? B, yes. So I'm going to write it as point B, or you can write it with the squigglies with a B. Either way, that's acceptable. One more problem with and then just a bit of a question with this figure. I'm going to go to a fresh one just so that I don't make everybody go blind. So let's say I ask you this. If I have this angle FCD, and I'm going to intersect it with angle HCD. Intersecting those two angles. Tell me what the result is when I do that, please. Okay, angle FCD is, here's F, here's the vertex C, here's D. So there's the first angle that I mentioned. And then here's the second one, HCD, starts down here at H and C and D. And now, according to, I've got some blue up there, I've got some green up there. According to that, what do those two angles share? Yeah, they share this side right here, and that is exactly as I was told. That is ray CD. Now, rays, it's important that you label them that way because where they start having things in common is the vertex C, and then it goes in the direction of D. So that is the correct notation. There is not another correct notation. The last thing we're going to do with this figure, and then we're going to move on. We got plenty of time. We're moving nice and slow here. Let's say I tell you, I'm just going to make a little angle mark right there. Let's say that I tell you that that is 28 degrees. What I would just like you to do is off on the side, I would like you to write in the appropriate notation how you would communicate the measure of that angle is 28 degrees. So it's this one right here that I've drawn the little arc in. So what you have two things to do. You've got to define what angle that is, and then you've got to write appropriately that its measure is 28 degrees. So however you wrote this, you first wrote a little m, I'm hoping, for measure, and angle. Now there's a couple different ways that you could define this angle. Okay, so notice on this side, you've got G and F up here. So you could have either started with either F or G. It doesn't matter. I'm going to start with F. The only thing you have to have, this is the thing that is imperative, is B has to be in the middle because that is the vertex down there. And then on this side, you've got either C or D that you could use. So I'll use D. So you've either got, like I do, FBD, or you have FBC maybe, or GBC or GBD, or you could have them reversed. Maybe you started at this side and did DBF. That is fine. The only thing that matters is that B is in the middle. And then you just want to say, okay, that's equal to 28 degrees. Just wanted to make sure you had the opportunity to appropriately use the notation that we're dealing with here. All right, the grand finale, we're gonna approach the finish line here. Let me just change my camera one more time. We are not going to get to the parallel lines part of this, so
homework. Don't worry about the parallel lines. We will talk about that next time. So I would say do some of the homework for 8.1, but don't take the quiz yet because I do have a parallel line problem or two on the quiz, and I don't want you to get a poorer grade than you need to on the quiz because we didn't finish that. So we will get to it though. So here's the last bit that I'm going to tell you about. It's going to start with a little bit of terminology that we'll use more when we come back next time, and then just a couple final problems. So there's different types of angles. Okay, so there's something called acute angles. Acute angles have a measure that is between 0 and 90 degrees. So for instance, angle FBD that we just defined on the page, that would be called an acute angle. A right angle, the right angle has a measure of 90 degrees. You'll know in some of your figures that you have a right angle. The way it commonly gets notated is if you have a right angle, 90 degree angle, they'll put like a little square in there just to let you know that that's 90 degrees. So in case you see that notation, that's giving you some information that's useful to you. Obtuse. An obtuse angle has a measure between 90 and 180. And then we're down to our last bit. So once you've got caught up there, I've got two more things to tell you, and then we'll do a couple of problems. And this is where we'll pick up next time. We'll do a couple more of these problems that we end with, like we did today with section 7.4. So the last little bit is complementary angles. Complementary angles are two angles that add to 90 degrees. So if you are told that two angles are complements or they're complementary, then that is telling you that they add up to 90 degrees. That's giving you some information. And then here's the last one you're gonna have to write, and then we'll finish our last 8 minutes of class time with a couple of problems. So the last thing is supplementary angles. Are two angles that add to 180 degrees. So I'm going to erase over here while you're writing. I'm getting a writer's cramp. So I'm just going to draw a little picture here. This is just an example that I'm copying from the book, but you have to look online for the book, which is fun to do. They've made it a lot more. I was perusing it the other day. They've made it a lot more user-friendly to actually click into the book. You can click directly to a section. Before, you had to download the whole book to your computer. It was a real pain in the rear. But now you can just go section by section and you can scroll through. It's really easy to navigate. You can click on words. There's videos, examples. There's videos of the examples in the book. So it's a really great resource. Anyway, all that to say is, here's my picture. And I'm going to define this angle here to be 31 degrees. And then here's the problem that we're going to answer. If angle ABC is complementary with angle CBD, find the measure of angle CB. So I'll give you a second to write that down. That's all. More words than really the problem's kind of worth, but I want you to see how it's going to look. So this problem right here, we were given the picture, so that helps to jog our memory. And I've left the definition on the board, but when you see the word complementary, complementary tells you what about these two angles right here? Perfect, they add up to 90. So I'm looking for this angle right here. I know this one's 31. I don't know this one, but I know they add up to 90. So this is as much algebra. I know that's the A word. Okay, this is as much algebra as you have to remember in this class, and we'll use this a couple times in this semester, just basic solving equations. Here's how you're going to set this up. The question mark, the angle that I don't know, plus 31 degrees is equal to 90. Now, if you want to use a letter, X, I'm trying to avoid it because I know we have very caustic memories of doing algebra. Okay, so the angle I don't know plus 31 degrees is equal to 90. Okay. Now I know you can use your calculator, you can fiddle around with it and figure that out. That's totally fine. But I want to remind you of the steps to make life a little more, hopefully a little more pleasant. What do I do to both sides here to figure out what the question mark is? Yeah, you just do the reverse. This is adding 31, so to get it over there, you subtract 31. And so what this tells me is the angle that I don't know is equal to 90 minus 31, which is 59 degrees. So what's the measure of angle CBD? It's equal to 59 degrees. So I'm going to give you, we've got 6 minutes left. I'm going to do one more. I'm going to give you one problem and give you a couple minutes to sort through it. Okay, so here's your picture. Okay, so it's going to be the same sort of thing. I've drawn the picture right here, and so here's what I'm going to tell you. If angle ABC is supplementary to angle CBD, so it looks very similar to the last one, find the measure of angle ABC. Same sort of thing, only this time I've told you they're supplementary instead of complementary. All right, I know you've got your picture, but the word supplementary tells me what about the angles? Add up to 180, okay? I do want you to remember those words. Some of the problems in the book, they don't draw the picture for you. So I want you to remember that. So I'm again looking for this angle right here. So the angle that I don't know plus the 52, I'm adding up the two angles, and I'm told that that's equal to 180 degrees. What do I do to both sides to figure out the angle that I don't know? Subtract, yes, you just do the reverse. And so when I do that, I get that the angle that I don't know is 180 minus 52. I think that's 128 degrees. So that's the measure of angle ABC. So we have gotten almost all the way through 8.1. When we start up on Thursday, we'll do a couple more of these problems. We'll talk about parallel lines, which is the only thing we haven't talked about when you do your homework. And then 8.2 won't take us too long. Hope you have a great